Okay, our first example is a rectangle. We'll call this rectangle WXYZ. And the information they give us is that if ZP is 4x minus 9 and PY is 2x plus 5, find ZX. Well, ZX is this entire segment, this entire diagonal, which we can't find until we figure out what x is. So the property that we are visiting in a rectangle is that the diagonals are congruent. So diagonal ZX is congruent to diagonal WY. And since the diagonals bisect each other in a parallelogram, and a rectangle is a parallelogram, then we know that all four of these segments within the parallelogram or within the rectangle are congruent. So we would start by setting 4x minus 9 equal to 2x plus 5 so that we can figure out what x is. Okay, and once we solve that, we're going to get x is 7. And if you want to, go ahead and pause the video, take a minute to make sure that you get x is 7. And then once we know, because really the algebra isn't the part we really want to focus on, we really want to focus on the properties and actually applying them. So if x is 7, that means I can figure out what each segment is. So again, all four of these are going to be congruent. So if I can just figure out what either ZP is or YP is, I can multiply that by 2 and get the entire segment or diagonal ZX. So they told us ZP was 4x minus 9, so ZP is 4 times 7 minus 9. 4 times 7 is 28 minus 9, and that's going to be 19. So the first segment is 19. And if each of these segments is congruent to each other, then PX will also be 19. So the total length of ZX from here to here, the total length of ZX is going to be 19 times 2, or double 19, which is going to be 38. Okay, but you have to know that the diagonals are congruent in a rectangle. So all of these halves are the same. Okay, let's see another example of a rectangle. This time they're giving us angle measures. So the property that I'm guessing we're going to need to know is that each angle in a rectangle is 90 degrees. Usually that's what that means when they are asking anything about angles in a rectangle. So let's see if that's true. It may not be true, I don't know. Alright, so XZY, XZY, so this angle here is 3x plus 6. And XZW, X to Z to W, so this angle here is 5x minus 12. Now if this were a rhombus, we could say that these two equal each other, because in a rhombus the diagonals bisect the angles. But this isn't a rhombus, this is a rectangle. So the only thing we know about a rectangle is that each interior angle is 90 degrees. That's why we even have this symbol here. So these two together equal 90 degrees. So we would set 3x plus 6 plus 5x minus 12 equal to 90. Alright, I'm going to let you work on the algebra, pause the video, and see if you get the same thing that I do for x. And you should get that x is 12. But the question didn't say find x. The question says find the measure of YXZ. YXZ. So that would be this angle right here. And now what's going to end up happening is we're looking for the third angle in a right triangle. We already know that this angle is 90 degrees. And this angle is 3x plus 6, so it's 3 times 12 plus 6, which is 42 degrees. So I'm going to go ahead and replace this angle with 42 degrees. And now, essentially, this is the picture that we have. We have a 90-degree angle, 42 degrees here, and we're looking for the third angle of a triangle. That's what the question is asking us for, y, x, z. So your missing angle would be 90 minus 42. Because the triangle has 180 degrees in it, we subtract 90, we subtract 42, and you're going to get 48 degrees. So your final answer, measure of angle y, x, z equals 48 degrees. Okay, the next example. This time we're dealing with a rhombus. In rhombus ABCD, AC is 40, or sorry, AC is 30, and BD is 40. So it's a rhombus. That means that the diagonals are not congruent. But since it's a parallelogram, we know that the diagonals bisect each other. So the segments that make up one diagonal are going to be congruent. So if AC is 30 inches, then each of these segments will be 15 inches. And if BD is 40 inches, then each of these segments will be 20. And that part right there that I just did, that comes from the properties of a parallelogram. We're not really specific to a rhombus yet. So that's something that you should know just from a parallelogram. And then it says, what is the perimeter of a rhombus? The perimeter means how far along the outside is this rhombus. What is the perimeter of the rhombus? The distance around the rhombus, the walking distance, if you will. Well, we don't know what each side is, so we can't add up each side, but the property that's going to help us here is that in a rhombus, the diagonals are perpendicular. So that means what's happening here is we're creating some right triangles where we can call x our missing side of our right triangles. Because once we find out what x is, we can add them all together to find our perimeter. So basically, you're going back to last chapter, which was right triangles, given two sides, looking for the third. We're going to use Pythagorean theorem, where c squared equals a squared plus b squared. The thing that most of you missed if you missed Pythagorean theorem was that the opposite side of the right angle is your c. So across from the right angle is x, that's what we're going to call our c. And the order of a and b doesn't matter. So we can say 15 squared plus 20 squared. So just bringing everything down, x squared equals 15 squared. 15 squared is 225, and 20 squared is 400. So x squared equals 625. And since I'm looking for x, I have to take the square root of both sides. So I'll get x is 25. So that means that each side in this rhombus is 25 inches. So that means the perimeter of the rhombus is 25 plus 25 plus 25 plus 25, or 25 times 4, which is 100. And this was inches. So 100 inches is our perimeter. Okay, and our last property that we're going to deal with, this one's nice and simple, is the rhombus. In a rhombus, each angle is bisected. So that means that each of these halves is equal. Doesn't mean that every single angle in this picture is equal. It just means that the opposite angles are equal and the angles that have been cut are bisected. So it says if the measure of angle BCD, so B to C to D, this angle right here is 54. B to C to D is 54 degrees. Find BAC. They want this half of the rhombus. Well, in a parallelogram, opposite angles are congruent. So BAD, this is 54 degrees. And in a rhombus, each angle has been bisected by the diagonals. So basically all that's happening is this 54 has been cut in half. So the measure of angle BAC is 27 degrees.